So this is the last of the erosion notes in terms of the agents of erosion, and it comprises wind and ocean waves. So the wind is most common in dry climates, wind erosion. It's deserts and beaches because there's very little plant material. Because it's so dry, there's so few plants, so there's a lot of exposed soil, and that then lends itself to having wind pick up and carry that sand and cause that erosion. So the faster the wind blows, just like water, the larger the sediment it can carry. So then again, because of that, it's speed dependent, you get that sorted sediments, those sorted sediments. It usually can't move the very large particles, so we're talking silt, sand, clay materials that get picked up and carried. But there are places where you get very big dust storms, and those particles can get picked up and carried very, very far distances. So sand from the Sahara Desert can get picked up and carried to Europe. So they can get picked up and carried pretty far if the wind's blowing fast enough. So again, the largest particles settle out first. Weathering is mostly by abrasion. It's almost like sandblasting. If you've ever heard of sandblasting or seen it done, they take sand, they put it in, they take air, compressed air, and they blow the sand with air against something that needs to be sanded or smooth. Paint needs to be removed, and it does a great job of sanding it. And so sandblasting is that sort of abrasion that we've been talking about. Features tend to be pitted, which means they have little holes in them. And if you look at this, I don't know if you can see it, but you can see the little holes. That it's not an igneous rock. This is from sandblasting, so it was found in the desert Southwest. It gets rounded, smooth, pitted. Surface features include sand dunes and blasted bedrock. If you think of the desert Southwest, and I'll show you some pictures in class of that, that's those spires and features are key to that. And I'll pause this and pull a few up. But if you look here, if the wind is blowing in this direction, the sand dunes will generally form a gradual slope on one side, and then as the dune gets bigger and the wind starts to go over, it tends to be steeper on this side. And as this wind is blowing, it's picking up and rolling those sand grains, and then it slows down and drops over the side. So as the wind is blowing this way, the sand dune is generally more gradually sloped on this side than on the other. So I paused it for a moment just so that I could pull up some images from Google of wind erosion. So you can see, and generally what ends up happening is, as you can see here, it's narrower at the bottom. And the reason that is because in general, the particles are being picked up and carried close to the ground. Even when the wind is blowing moderately fast, these particles don't get picked up and carried very far because gravity's always pulling them down. So you're going to have the most erosion and most weathering because of that abrasion down at the surface. So you get these very odd shapes formed out in the west. And what they end up having to do is they have to actually protect their telephone poles, because this happens to telephone poles and it wears away and sands away at the bottom of the telephone pole, and then the telephone pole falls over. So that's wind erosion. The next is ocean waves. So ocean waves are caused when you have wind moving over the water, and it causes abrasion, and it moves sand. It picks up sand out here and brings it onto the shore. Generally, if you have barrier islands, or sometimes these islands get formed from ocean waves, and they can tend to slow down the waves and protect the beaches. And you get sand dunes as well out here. You'll get a sandbar, usually you can walk out and stand on the sandbar, and that slows the waves down. Okay. The beaches that form from weathering and erosion of continental and oceanic rock, generally the grains of sand are going to be the hardest minerals left over. And so when we look at granite, granite's made out of quartz and feldspars, and the quartz tends to be the hardest of the minerals and is less reactive, and so it ends up being the one that lasts and is the biggest component of sand. Sandbars are ridges of sand formed along the shore by action of waves and currents. They protect barrier islands from erosion. So those sandbars that are off the coast of an island tend to slow the waves down and then protect it. And barrier islands are these long, narrow islands that run parallel to the mainland. They're made of sand. They're built up by action of waves, currents, and wind that distribute the sand, and they tend to protect the coast from erosion. So we get these islands that form out here from sand over hundreds and thousands of years building up. Then plants will start to grow on that, and then you'll get a more developed island. And as the waves come in, they hit these islands first, slow down, and protect the mainland. One of the things that I want you to see here in New Orleans, this is one giant delta. As the sediment is flowing out of these rivers, it hits the ocean, slows down, stops, and the sediments that are picked up by the Mississippi get dropped here. And this whole area is caused by erosion up in the United States, picking up soil and sediment, carrying it down to the ocean. When it hits the ocean, it slows down and drops that material. And it drops so much of it that it built this whole area. This whole thing is a delta that was created by the Mississippi over thousands and thousands of years, millions of years probably. So this is a great example of erosion deposition, affecting and changing an area. So that's just how wind-driven waves help to either create islands and/or these islands help to protect these landscapes, because as the waves crash along here, they can break down this land and wash it back out to sea. Okay, I think that's it.